Hello, I am Jahangir. Today I am going to discuss IGCSE O-Level Physics, Unit 1, Forces and Motion. Chapter 1, Movement and Position. Here is the learning objectives in the chapter. Plot and explain distance time graph. After finishing this chapter, you can plot and explain the distance time graphs. Know and use the relation between average speed, distance moved and time taken. So here there is a relation average speed equal to distance moved divided by time taken. There is a practical. Investigate the motion of everyday objects such as toy cars or tennis balls. Know and use the relation between acceleration, change in velocity and time taken. Here acceleration equals to change in velocity by time taken. Here acceleration is denoted by A equals to V minus U divided by T. After finishing this chapter, you will plot and explain the velocity time graphs, determine the acceleration from the gradient of the velocity time graph. So if we want to find out the acceleration, then we have to calculate gradient of the velocity time graph. Determine the distance traveled from the area between the velocity time graph and the time axis. Use the relation final speed square equal to initial speed square plus 2 into acceleration into distance moved. That means v square equal to u square plus 2as. In this chapter, first we have to learn about scalar quantity and vector quantity. What is scalar quantity? What is scalar quantity? The physical quantity which can be fully expressed by magnitude only are called scalar quantity, like length, mass, speed, work, energy, time, temperature, etc. are the example of scalar quantity. So there are another quantity, it is very important for physics, vector quantity. The physical quantities which need both magnitude and direction, that means which need magnitude and direction to represent completely is called vector quantity. It's called vector quantity. So remember this one. So a vector quantity here some example of vector quantity. Displacement. There is a displacement is a vector quantity. Weight, velocity, acceleration, force, electric intensity, magnetic intensity, all type intensity are there is a direction. So it is the example of vector quantities. So vector quantity has both magnitude and direction. Here there are some example of scalar quantity. Say distance, we write only 40 meter, speed 30 meter per second. So to express scalar quantity, we need magnitude plus unit only. But to express vector quantity we need magnitude plus unit and direction. So remember this one. So mainly vector quantity has both magnitude and direction. Clear? Now there are some important example of scalar quantity and vector quantity. Here scalar quantity has only magnitude. Magnitude means value. Magnitude means value. That means number. Value means number. Number. On the other hand, vector quantity has both magnitude and direction. Scalar quantity, example of some scalar quantity: distance, unit meter; speed, unit meter per second; time, second; mass, kg; temperature, Kelvin; pressure, Pascal or Newton meters per meter square; kinetic energy, joule; gravitational potential energy, also joule; work, joule; power, joule per second or watt; current, ampere; potential difference, volt; resistance, ohm. On the other hand, vector quantity: displacement, velocity, acceleration, force, weight, momentum also a vector quantity, unit kg meter per second. So remember, this is very important. Then there is a difference. Already we discussed about this. Scalar quantity and vector quantity. Difference between scalar quantity and vector quantity. Scalar quantity has only magnitude but no direction. Scalar quantity has only magnitude, no direction. On the other hand, vector quantity has both magnitude and direction. Every scalar quantity has in one dimensional. Vector quantity can be one dimensional, two dimensional or three dimensional. Any change in scalar quantity is the reflection of the change in magnitude, because it has only magnitude. So if we change magnitude, then scalar quantity will be changed. On the other hand, any change in vector quantity can be reflect either change in direction or change in magnitude, or changes in both. Very important. So scalar quantity cannot be resolved as it has exact same value regardless of the direction. So only a magnitude. Vector quantity resolve in any direction using sine or cosine or adjacent angle. That means resolution. Resolution is like we can find out the horizontal component and vertical component of a vector quantity. If f is a force or any vector quantity, so it is x-axis, it is y-axis, then the angle between the vector f and x-axis is theta. Then we can find out the horizontal component f cos theta, and vertical component f sin theta. So that's why we can there is a resolution or component in any direction. So vector quantity can be resolved in any direction using sine or cosine of the adjacent angle. Okay, any mathematical operation like addition, subtraction, multiplication, division of scalar quantity will provide normal algebraic rule. It follows normal algebraic rule. So they follow normal algebraic rule. But vector quantity, the addition or the all type operation, mathematical operation like addition, subtraction, multiplication, division, they follow special vector algebra or geometrical rule. So there are some example of scalar quantity like length, mass, energy. Remember, energy, work, these are scalar quantity. Density also is scalar quantity. So on the other hand, vector quantity, displacement, velocity, acceleration, force, these are vector quantity. So there are some solid example of scalar and vector quantity. So same thing, difference between scalar and vector. So now in this chapter, most important thing we have to understand about rest and motion. We know rest, if a body does not change its position with surrounding environment with time, then it is said to be object is rest. On the other hand, a body is said to be in motion with respect to its surrounding when it changes its position with time. Now the basic part of this chapter, distance and displacement. Distance, total path covered by an object irrespectively to its direction is called distance. That means without considering direction from A to B, we can follow any path. So distance, if we do not consider the direction, that means irrespective to direction, then it is called distance. So A to B, so it is a scalar quantity because it has no direction. It is a scalar quantity. On the other hand, displacement, the total path covered by an object in a particular direction, in any specific direction, is called vector quantity. Is called displacement. Displacement is a vector quantity because it has both magnitude and direction. So displacement is the shortest path between two points. Unit of displacement and distance is same, a meter, but it has direction. It has particular direction. Now speed and velocity. The rate of change of distance, that means it is related with distance. The rate of change of distance with time is called speed. The formula is speed equals to distance moved divided by time taken. So symbolically we can write speed is denoted by V, so distance is denoted by D divided by time T. So unit of distance is meter and unit of time is second, so meter per second. Now most important thing, average speed. If a body does not move with uniform speed, then the average speed is obtained dividing the total distance traversed by time. So average speed equal to, equal to total distance moved divided by time taken. Distance moved divided by time taken. So unit same, meter per second. On the other hand, velocity, the distance traversed by a moving body in a particular direction, definite direction, is called velocity. So the rate of change of displacement is called velocity. Velocity is a vector quantity. It has a definite direction. Relation V equals to S divided by T. S here displacement, so it is a vector quantity. Velocity also vector quantity. Unit meter per second. There are some special type velocity: uniform velocity, non-uniform velocity. If the magnitude and direction of the velocity of a moving body remains unchanged, then it is called uniform velocity. That means if the rate of change of distance remains same for a certain period of time, then it is called uniform velocity. If the rate of change of displacement or rate of change of distance in a particular direction remains same, then it is called uniform velocity. Non-uniform velocity, if the magnitude or direction or both of the velocity of a moving body changes during its motion, then it is called non-uniform velocity.